So, dear students, we are discussing the chemical properties of non-metals. Dear students, पिछले दो लेक्चर्स में हमने देखा कि जो metals होते हैं they react with atmospheric oxygen on heating and they form oxides. And these oxides they may be acidic in nature or they may be neutral. For example, if we take uh, the non-metal carbon, it forms carbon dioxide as one of the oxide when carbon is heated with atmospheric oxygen and the oxygen being in excess amounts. However, if the oxygen supply during the reaction is limited, so we get carbon monoxide. This carbon dioxide, it is an acidic oxide because when it is dissolved in water, it forms H2CO3, that is carbonic acid. However, this uh, carbon monoxide, this does not react with acids or bases. That is why carbon monoxide is considered as a neutral oxide. So, dear students, we have also seen that the non-metals, when they are treated with water, these non-metals they generally do not react with water, because if we see the reaction of metals with water, and in such reactions H2 gas is evolved. Dear students, if we take the similar case here in the reaction of non-metals with water, what happens here? H2, H positive proton, it needs to be reduced to H2 gas, so it needs electrons. So there, in these reactions there must be electron donators. However, these non-metals, they are electron acceptors. That is why generally they do not react. However, there are certain strongly reactive non-metals like fluorine. It can react with water and it forms hydrogen fluoride and oxygen and ozone molecules. Dear students, non-metals, if treated with dilute acids like H2SO4, HCl, or HNO3, here again we do not see any reaction. Why we do not see any reaction? Because these non-metals, they are not able to displace this hydrogen from these acids, so we can say they are not able to uh, displace hydrogen. We can say hydrogen gas evolution is not seen in these reactions. Here we can give the similar explanations. Here hydrogen acts as a proton, so to convert it into H positive, it needs electrons, so it must be reduced. Since non-metals being electron acceptors, so they cannot donate electron to H positive, so that it gets converted into H2 molecule. So when non-metals, they are treated with dilute acids, no reaction takes place. So the fourth reaction is that when non-metals or treated with chlorine, and we obtain chlorides. And these chlorides, they are volatile liquids and gases. Dear students, you must remind that we have studied in the previous class that these chlorides are covalent in nature, or covalent compounds. So here what happens between non-metal and chlorine? The bonds which are formed, they are covalent in nature, means that they are formed by sharing of electrons. So these compounds, they do not contain ions, that is positive and negative ions, and that is why these are non-conducting. They do not conduct electricity, and we call them as non-electrolytes. We call them as non-electrolytes. So dear students, coming to fifth reaction, reaction of non-metals with hydrogen. So when non-metals are reacted with hydrogen, we obtain covalent hydrides. And these hydrides, they are generally gases or liquids. And similarly, like chlorides, these are covalent compounds. They do not contain ions, and they thus do not conduct electricity, and we call them non-electrolytes. Similarly, here covalent hydrides, these covalent hydrides, we have covalent bonds between the hydrogen, between the non-metal and hydrogen, covalent bonds. So these compounds, they do not contain ions, positive and negative ions, and that is why they do not conduct electricity, or they are non-electrolytes. So let's see some examples of the reaction between non-metals and hydrides. Dear students, if we take hydrogen and we react it with liquid sulfur at a temperature of 713 Kelvin, and we obtain hydrogen sulfide. This is the covalent hydride. And in another case, if we take hydrogen and it react hydrogen with a nitrogen gas at 232 to 723 to 773 kelvins, and we also use iron as a catalyst, and here we obtain ammonia. So if I write the reaction, so it is H2 gas, this is the hydrogen non-metal, plus nitrogen gas, this is non-metal, this is also non-metal, and we obtain NH3, this is gas. So here we have three hydrogens, so it is 2 It is thrice two nitrogen atoms, 3 times H2. So this is the balanced chemical equation, and we use 723 to 77 Kelvin temperature and iron as catalyst. If we write here the equation, it is hydrogen gas plus dear sulfur, student sulfur acts as S8 molecule, S8, and it will form hydrogen sulfide, that is H2S. So here are 8 sulfur atoms, it is 8 times, and this is 8 times. So this is the reaction of hydrogen with non-metals, and we obtain covalent hydrides, which are non-conducting, thus referred as non-electrolytes. Dear students, now coming to the sixth chemical reaction of metals, that is reaction of non-metals with salts. Dear students, if we take a non-metal and we treat it with a salt solution of another non-metal, and if this non-metal, if it is highly reactive and the salt of this metal, the metal of which is less reactive. So in this reaction we are adding a highly reactive non-metal with a salt solution of less reactive metal, and here what happens, this highly reactive metal, it displaces. So highly reactive metal displaces less reactive metal from its salt solution. So हम एक हाईली रिएक्टिव मेटल को एक लेस रिएक्टिव मेटल के सॉल्ट सॉल्यूशन में ऐड कर रहे हैं, तो यहाँ पे क्या हो रहा है, जो हाईली रिएक्टिव मेटल है इट डिस्प्लेसेस द लेस रिएक्टिव मेटल फ्रॉम इट्स सॉल्ट सॉल्यूशन. फॉर एग्जांपल, we are taking sodium bromide and we add chlorine gas to it. What happens, this is less reactive non-metal, that is the bromine. And dear students, this chlorine it is highly reactive. So chlorine is more reactive than bromine. So what happens, this chlorine, it will displace a bromine from this salt sodium bromide, so we can get NaCl plus Br2. Br is liquid, NaCl is salt, and we can balance this reaction. It is twice. So this is how non-metals react with salts. And dear students, now the final chemical reaction of non-metals, that is the oxidizing nature of non-metals. Oxidizing nature of non-metals. Dear students, you know that oxidation is loss of electrons. Suppose if we take any species, that's A, we treat with any other, suppose it is non-metal, and they form a sort of product what happens? Suppose A loses electrons, we can say that oxidation of A takes place. Dear students, this oxidation takes place only and only when in its vicinity there is an electron acceptor. So here we have a non-metal, it accepts electron, so it facilitates the oxidation of this A. So we can say that these non-metals are oxidizing agents. Why they are oxidizing agents? Because